The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
I'm going to work through problem number 15 for midterm exam 1, physics 2020. And this problem says 5 blocks, each 10 centimeters thick, with a mass of 1.5 kilograms, lie flat on a sidewalk. How much work is required to stack them on top? How much work is required to stack them one on top of another? Alright, so I've drawn a little illustration here of the problem statement. So basically, we have 5 blocks, and we want to stack them on top of each other. And we want to determine how much work is it going to take to actually stack the blocks on top of each other. Alright, and so basically what we want to find is we're going to take one block, stack it on another block, stack it on one block, then take another block and stack it, and we're going to keep doing that until we get 5 blocks high. And so actually what we're doing is we need to determine the total amount of work it takes to stack these blocks. And so initially, how much work does it take to stack the first block? Well, it doesn't take any work, the block is already laying there. And then how much does it take to stack the second block? Well, that's basically the work it takes to lift the block, the second block onto the first block. And similarly, we go all the way up until we get to 5 blocks high. So the total work, okay, so TW is for total work, is going to be the sum of the work that it takes to stack all blocks. Okay? Sorry. So that's going to be the total work. Now, we know that the mass is equal to 1.5 kilograms, and we know that work is defined as the force times the perpendicular distance of that force. Okay, so basically the force is defined as the work is defined as the force times the distance you're applying that force. All right, and so we also know that the force is equal to mass times acceleration, or in the case of when we're lifting something, it's mass times the speed due to gravity. All right, and so we can find the sum of the total work if we find each individual work for lifting the blocks. All right, and so let's determine, so in each case we're going to have to determine the force. And so the force is going to be the mass of a block times gravity, which is equal to 1.5 kilograms multiplied by 9.8 meters per second squared. And so we know that the force is going to be 14.7 newtons. All right? And so let's basically set up so the force of the initial force, or the initial work, is going to be your initial force times the distance traveled, which is going to be 14.7 newtons multiplied by 0, because you're not actually have to lift the first block, so that's going to be 0. The first work is going to be that force, and this is going, all the forces are going to be the same because you're only lifting up one block at a time. And so that's going to be multiplied by the first distance, which is going to be 14.7 newtons, multiplied by the first distance. Well, the first distance with the block is 10 centimeters, or 0.1 meters. And since we're working in newtons and we want to have our units consistent, newtons are kilograms meters per second squared. Okay, that's what a newton is. And so we need to have our displacement units in terms of meters. They give each block in terms of centimeters, so we just convert centimeters to meters. So the first distance is 0.1 meters, and that actually works out to be 1.42, and we call this unit joules, okay, of work. And we just repeat this process for each successive work. So the second work is going to be equal to the force, which again is 14 newtons, multiplied by the distance traveled, which in this case is going to be, now you're lifting over 2 blocks, so it's going to be 0.2 meters, which is going to be 2.94 joules. The third work is going to be 14.7 newtons multiplied by the distance. So in this case, you're going to go up 3 blocks, and so that's going to be 0.3 meters, which is going to be 4.41 joules. And the fourth one is going to be 14.7 newtons multiplied by 0.4 meters, because you're having to lift the block now over 4 blocks, and that works out to be 5.88 joules. Okay? Now, when you total all these up, so the total work, it's just going to be the sum of all of these, and when you take the sum of all of those, you get 14.7 joules. Alright? And that is the answer to this problem.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.